Something is happening right now that has every space agency on edge. The interstellar object known as 3IATLAS, believed to be the third confirmed visitor from beyond our solar system, has done something no one expected. It changed course. Not slightly, not subtly, but in a way that seems to challenge everything we know about the laws of celestial mechanics. For the first time in history, the International Asteroid Warning Network, a global defense coalition endorsed by the United Nations, has begun tracking an object that came from another star system. Normally, this network focuses only on asteroids and debris within our own solar system that might threaten Earth. But now, all attention has shifted to this mysterious traveler. The reason is simple and unsettling. New data suggests that 3IATLAS is not where it is supposed to be. According to orbital predictions from NASA's Jet Propulsion Laboratory and other observatories, the object should have followed a precise and predictable path. Instead, its position began drifting away from where the math said it should be. If the calculations are correct, the object may have altered its trajectory while passing near the Sun. If that really happened, then what scientists are seeing may not just be an astronomical anomaly. It could be something intentional. The International Asteroid Warning Network, often called IAWN, exists for one purpose: to detect and prepare for threats that could endanger life on Earth. It brings together the most powerful observatories in the world, including those operated by NASA, the European Space Agency, and China's Purple Mountain Observatory. Until now, the network has only monitored near-Earth asteroids and natural debris formed inside our solar system. But in late October 2025, the network made an unusual announcement. For the first time ever, it would begin tracking an interstellar object, 3IATLAS. Officially, the reason was to improve astrometric precision when observing comet-like bodies. But the timing immediately raised suspicions. Just days earlier, 3IATLAS had disappeared behind the Sun, making it impossible to observe directly. At the same time, independent astronomers began reporting small deviations from the object's predicted position. When it finally reappeared, something strange had happened. The math no longer worked. Harvard astrophysicist Avi Loeb, known for studying unusual cosmic objects, had previously rated the possibility that 3IATLAS might be artificial at 4 out of 10 on his speculative Loeb scale. After the new anomalies appeared, the object quietly became a priority target. Telescopes around the world were redirected to track it, almost as if the scientific community sensed that something unusual was unfolding. The first major alarm came from an independent group of astronomers known as Earth Exists, a small but respected research collective. They compared live telescope observations with predictions from NASA's Horizon orbital system. What they discovered shocked everyone. 3IATLAS was not just slightly off course. It was about 1.1 million kilometers away from where it should have been, roughly 3 times the distance between Earth and the Moon. Even stranger, the displacement was not random. The object's distance from Earth remained almost the same, but its position across the sky had shifted sideways. It was as if the object had moved laterally through space. That should not be possible. Comets sometimes drift forward or backward when gas jets erupt from their surfaces, acting like natural thrusters. But those jets cannot push an object sideways with precision. To cause that kind of movement would require either a massive external force or some kind of internal propulsion. For comparison, even the largest comet ever recorded, Hale-Bopp, could never produce that level of controlled movement. Yet somehow, 3IATLAS had done exactly that. If the object truly shifted its orbit intentionally, someone might have noticed earlier. And that is when attention turned toward NASA and its monitoring systems. As early as September, NASA's Mars orbiters were perfectly positioned to photograph the object during its solar flyby. But those images have never been released. Not a single frame. Officially, the data is still being analyzed. But some researchers suspect something else may be happening behind the scenes. In one of his publications, Avi Loeb mentioned another strange detail. The object appeared to produce an anti-tail, a rare phenomenon where dust appears to point toward the Sun instead of away from it. After the Mars encounter, however, the tail suddenly flipped direction again, now flowing away from the Sun as expected. It looked as if the object had reoriented itself in space. No natural comet has ever reversed its jet direction so perfectly. Despite this, NASA has continued to describe the behavior as routine comet activity. Still, one question remains. If it is routine, why is the Asteroid Defense Network involved at all? By the end of October, new tracking data confirmed everyone's fears. The deviation was real. Over a period of just 19 hours, the positional difference widened by more than 4 arc-minutes, equivalent to hundreds of thousands of kilometers. Orbital analysts calculated that maintaining this drift would require a sideways velocity of nearly 4 kilometers per second. That is more thrust than some of our own deep space probes can generate. Theories spread quickly across the scientific community. Some scientists blamed outgassing. Others suggested solar wind pressure. But solar wind cannot push objects sideways with that level of precision. If the measurements are correct, 3IATLAS would need some kind of propulsion system capable of sustained acceleration and controlled maneuvering. Meanwhile, the International Asteroid Warning Network organized emergency workshops to train astronomers on tracking unpredictable comet behavior. Behind the scenes, NASA's Planetary Defense Office quietly raised its monitoring level, the same level normally reserved for potentially hazardous asteroids. The strange part is that the object was moving away from Earth, not toward it. So why treat it like a threat? Some analysts believe the answer appeared soon after. Just when astronomers thought the anomaly had stabilized, 3IATLAS changed direction again. This time the shift was not random. It was a perfect correction. Ground-based observatories in Chile, Spain, and Japan detected a second deflection. It was smaller than the first but aligned perfectly with the object's original trajectory, as if the object had corrected its own path. The movement looked calculated and precise, the kind of maneuver an automated spacecraft might perform after checking its navigation system. Inside the Asteroid Warning Network, the event was labeled a pattern recognition anomaly, meaning the behavior did not match any known natural process. At the same time, the European Space Operations Centre released an internal update confirming that the object had produced measurable acceleration that could not be explained by gravity alone. In simple terms, the object had fired something. Infrared observations from the Very Large Telescope in Chile revealed a sudden burst of heat lasting about 12 minutes. After that, the temperature dropped quickly, as if an engine had ignited and then shut down. Whatever 3IATLAS was, it had just proven that it could move on its own. As soon as this information spread, space agencies around the world reacted. NASA doubled its monitoring schedule. China reactivated its U-22 radio array, normally used for lunar missions, to scan deep space frequencies along the object's path. The European Space Agency activated emergency planetary defense protocols. Officially, these actions were meant to coordinate observations. Unofficially, many scientists admitted the situation felt much more serious. Researchers began comparing the heat pattern of the burst to known propulsion systems. It did not match chemical rockets or ion engines. Instead, it looked similar to a magneto-hydrodynamic acceleration signature, a theoretical system where charged plasma is guided by electromagnetic fields. It is the same technology scientists have only imagined for future interstellar travel. Then another strange pattern appeared. The object's rotation rate, which had previously been stable, began fluctuating in repeating cycles every 247 seconds. At first, astronomers believed the object was tumbling, but the pattern was too precise. Some scientists wondered whether the motion itself might be sending a signal. As observations continued, analysts discovered something even stranger. The object's new trajectory would bring it extremely close to Jupiter. Within months, 3IATLAS would pass through the planet's powerful magnetosphere. If this was intentional, it might be performing a gravity assist, the same maneuver spacecraft use to gain speed by using a planet's gravity. At that moment, global monitoring reached what NASA calls Level 3 contingency, meaning the object's movement was active and unpredictable. Then, without warning, every observatory tracking 3IATLAS suddenly went dark. Within 10 minutes, telemetry from Hawaii, Chile, Italy, and South Africa froze at the same time. The Deep Space Network lost contact. Even China's radio arrays reported complete silence across multiple frequencies. When the data streams finally returned 47 minutes later, they all showed the same thing. 3IATLAS had vanished. It had not exploded. It was not hidden behind the sun. It simply was no longer at any of the coordinates where it should have been. Yet a faint echo remained, a low-frequency pulse repeating every 247 seconds, matching the object's last known rotation period. Scientists first thought it was background interference, but the timing was too precise. It was as if the signal was still out there, echoing through space. The International Asteroid Warning Network officially classified the event as Interstellar Signal Anomaly 2025-11 and restricted access to the data. But one detail leaked. During the blackout window, telescopes briefly recorded a faint flash aligned perfectly with Jupiter's orbit. The object had not disappeared. It had jumped. In the hours that followed, confusion spread throughout the global astronomy community. The Asteroid Warning Network released no official statement. NASA remained silent. China's Deep Space Network issued only a single line before wiping its records. Tracking anomaly terminated. Object unobservable. For a full week, no one knew where 3IATLAS had gone. Then, late one night, the James Webb Space Telescope detected a faint reflection moving just beyond Jupiter's orbit. When analysts examined the motion, they were stunned. The object had not slowed down or drifted gradually. It appeared to have changed position instantly, faster than light could travel. For days, scientists tried to explain the data. Perhaps it was a sensor error. Perhaps background radiation had fooled the instruments. But then confirmation arrived. The European Space Agency's Gaia Observatory, located about 1.5 million kilometers from Earth, detected an identical reflection exactly 247 seconds after Webb's observation. The timing was perfect. It was as if the object had duplicated its presence across space using the same repeating frequency it had been broadcasting. Every time the pulse appeared, it did not fade. It multiplied. Some scientists began suggesting an even more extraordinary possibility, that 3IATLAS had learned to use gravity itself as a bridge, moving through the fabric of spacetime. Then came the most disturbing discovery. Inside the Asteroid Warning Network's command center in Vienna, analysts reconstructed a fragment of data from the missing 47 minutes when observatories went silent. What they found was not telemetry or images. It was a binary transmission. The signal was embedded inside the network itself and synchronized with the object's 247-second pulse. When decoded, the binary pattern revealed coordinates. But not just coordinates in space. Coordinates in time. At first, analysts believed the data was corrupted. But as reconstruction continued, the meaning became clearer. The coordinates matched Jupiter's orbit, but the timestamp pointed 6 years into the future. Even more alarming, the final calculation shifted the target. It was not Jupiter. It was Earth. The data appeared to mark a future point in 2031, where 3IATLAS would intersect Earth's orbital plane. The file was immediately locked under Asteroid Hazard Level 10, the highest classification used for civilization-level threats. Every space agency publicly denied the existence of the data. But 3 months later, amateur astronomers in Australia began detecting faint radio echoes repeating the same 247-second pulse. This time the signal came from inside the asteroid belt. It was no longer drifting away. It was circling back. Soon after, the Asteroid Warning Network went completely dark. Public data feeds disappeared, observation logs vanished from the internet, and officials claimed the system was undergoing restructuring. Insiders later suggested that a private network of encrypted observatories had been created outside government jurisdiction. Its code name, Project Helios. Its mission is simple: to track whatever 3IATLAS has become and prepare for its return. Because maybe the object was never fleeing from anything. Maybe it was mapping our solar system, studying our gravity, our orbit, and our resonance. Maybe it was waiting for the right alignment. Even now, Every 247 seconds, a faint pulse continues to echo through the solar system. It is so weak that it blends with the cosmic background, yet strong enough to remind us that the story is not over. The world may have forgotten about 3IATLAS, but the universe hasn't. And if this story made you question what might truly be moving through the darkness between the stars, what kind of intelligence could guide something across interstellar space, then don't look away. Because when 3IATLAS returns, it might not just pass by.